Deep in the vast ocean of stars, where light takes millions of years just to reach our eyes, lies a cosmic whirlpool so mesmerizing it defies imagination. The Whirlpool Galaxy, known to astronomers as M51, isn't just another spiral of stars, it's a living puzzle, a celestial dance of mysteries waiting to be unraveled. Picture this, a galaxy so vivid you can almost see its arms twisting through space, yet hiding secrets so profound they challenge everything we think we know about the universe. From bizarre radio signals to unexplained bursts of energy, this galactic neighbor is a treasure chest of the strange and the spectacular. What if I told you that some of the most bewildering phenomena in the cosmos are happening right now, just 23 million light-years away? The Whirlpool Galaxy isn't just a pretty face in the night sky, it's a hotspot for cosmic oddities that leave even the brightest scientists scratching their heads. Imagine clouds of gas moving in ways that shouldn't be possible, or regions where stars vanish without a trace. This isn't science fiction, it's the reality of a galaxy that refuses to play by the rules. And that's exactly what we're diving into today. Over the next 30 revelations, we'll journey through the most head-scratching, awe-inspiring, and downright bizarre phenomena lurking within the Whirlpool Galaxy. Each one is a piece of a grander cosmic puzzle, blending cutting-edge science with the thrill of the unknown. So buckle up, because by the time we're done, you'll never look at this swirling masterpiece in the sky the same way again. The universe is whispering its secrets, and together we're about to listen. The first mystery lurking within the Whirlpool Galaxy is a cosmic beacon so powerful, so baffling, it threatens to rewrite our understanding of black holes. Near the galaxy's chaotic core, astronomers have spotted an ultra-luminous X-ray source, what scientists call a ULX, pumping out more energy in a single burst than our Sun will produce in its entire lifetime. And here's the kicker, this thing shouldn't exist, at least not according to the rules we thought governed black holes. Current models say black holes come in two sizes: stellar mass, the remnants of collapsed stars, and supermassive, the monsters anchoring galactic centers. But this ULX, it's too bright for a small black hole, yet too compact to be supermassive. It's like finding a candle as bright as a spotlight, defying every law of physics we know. So what is it? Some theorists suggest an intermediate mass black hole, a cosmic missing link trapped in the act of devouring a star. Others whisper about exotic matter, particles we've never seen, funneling energy in ways that bend reality itself. Then there's the wildest idea, a runaway black hole kicked from its home during some ancient galactic collision, now careening through the whirlpool's spiral arms like a rogue bullet. But the truth is, no one really knows. Every time we point our telescopes at it, this enigma throws another curveball, challenging even our boldest theories. And that's what makes the Whirlpool Galaxy so thrilling. It's not just showing us the universe's wonders, it's teaching us how much we still have left to learn. Now shift your gaze from the galaxy's mysterious core to its sweeping spiral arms, those elegant, star-studded ribbons that make the whirlpool so iconic. But look closer and you'll spot something off. One of those grand arms has a gap, a stretch where stars thin out like a highway fading into desert sand. Astronomers call it the phantom spiral arm, and its existence throws a wrench into everything we thought we knew about how galaxies evolve. Spiral arms aren't just pretty decorations, they're cosmic traffic jams, regions where gas and stars pile up like cars on a freeway. Normally, they flow in unbroken arcs tracing the galaxy's rotation. So when a chunk of one goes missing, it's like finding a bridge with a middle section mysteriously blown away. What could rip a spiral arm apart? Some researchers point to gravitational chaos. The whirlpool isn't dancing alone. It's got a smaller companion galaxy, NGC 5195, tugging at its edges like a mischievous child pulling yarn from a sweater. Could their gravitational tango have torn this gap into existence? Simulations suggest it's possible, but here's the twist: the damage doesn't quite match the math. The disruption should be messier, like a shattered windshield, not this clean, almost surgical absence. That's where the dark matter theorists step in. If invisible, intangible dark matter clumps around the galaxy in uneven pockets, its gravity could carve out these voids without leaving a trace. Imagine a river flowing smoothly until it hits an unseen rock. Water parts around it, creating a calm patch in the current. Could dark matter be that hidden force sculpting the galaxy in ways we can't see? Yet even that doesn't explain everything. Some stars in the Phantom Arm's vicinity orbit at odd angles, as if shoved by some long-vanished intruder. It's left astronomers debating whether we're seeing the aftermath of a galactic hit and run, a collision so ancient its scars have nearly faded, or evidence of something even stranger, a ripple in the very fabric of spacetime itself, warping the galaxy's structure from within. The Phantom Arm isn't just a gap, it's a mirror held up to our ignorance, reflecting how much we still don't understand about the forces shaping galaxies. Every explanation dances on the edge of possibility, teasing us with answers just out of reach. And that's what makes the Whirlpool so extraordinary. It doesn't just hide its secrets. It dangles them in plain sight, daring us to look deeper. Now let's zoom in on one of the Whirlpool Galaxy's most explosive secrets, a region so volatile it's earned the nickname the Supernova Factory. In just 17 years, astronomers have witnessed 3 separate stars detonate in cataclysmic supernova within this galactic whirlpool. To put that into perspective, our own Milky Way averages maybe 2 supernova per century. The whirlpool, it's cranking them out like fireworks on the 4th of July. What makes this galaxy such a hotspot for stellar explosions? It all comes down to density. The whirlpool's spiral arms are packed with gas clouds so thick, they're like cosmic nurseries on overdrive. Stars form here at a frenzied pace, many of them massive, short-lived giants destined to go out with a bang. Unlike the quiet suburbs of our Milky Way, where stars have room to breathe, this galaxy's core and arms are a mosh pit of stellar activity, crowded, chaotic, and ripe for disaster. But there's another twist. These supernovae aren't just random fireworks. They cluster in specific regions, often near vast reservoirs of molecular gas. When a massive star dies, the shockwave can compress nearby gas clouds, triggering a chain reaction of new star formation and ultimately more supernova. It's a self-perpetuating cycle, death breeding life, which then breeds more death. Yet even this doesn't fully explain the whirlpool's extreme output. Some researchers suspect the galaxy's gravitational dance with its smaller neighbor might be stirring the pot, jostling gas clouds and igniting star formation like a match tossed into dry brush. Others point to the galaxy's unusually high metallicity, a fancy term for heavier elements floating in its gas. These elements act like cosmic fertilizers, accelerating the birth and explosive death of massive stars. Then there's the wild card, magnetars. A handful of these ultra-dense, hypermagnetic stellar corpses have been spotted near past supernova sites in the whirlpool. Could their intense magnetic fields be juicing up these explosions, turning routine stellar deaths into supercharged light shows? It's a tantalizing possibility, one that could rewrite how we understand the final moments of a star's life. Every explosion in the supernova factory isn't just a spectacle, it's a data point, a clue about how stars live, die, and shape the galaxies around them. And in the whirlpool, that cosmic laboratory is running experiments at a pace we've never seen before. At the very heart of the Whirlpool Galaxy, something extraordinary is happening, a cosmic waltz so violent, so mesmerizing, it sends ripples through space-time itself. 2 supermassive black holes, each weighing millions of times more than our Sun, are locked in a gravitational embrace, circling each other like duelers in an endless cosmic standoff. This isn't just a rare celestial spectacle, it's a laboratory for some of the most extreme physics in the universe. Most galaxies host a single supermassive black hole at their center, but the Whirlpool's twin monsters tell a different story, one of galactic collisions and mergers. Astronomers believe this binary system is the aftermath of an ancient encounter when a smaller galaxy plunged into the Whirlpool, leaving its own black hole stranded in orbit around the larger one. Now, these two titans whirl around each other at dizzying speeds, separated by a distance smaller than our solar system. The energy they release as they spin isn't just light or heat, it's gravitational waves, distortions in the fabric of space-time that stretch and squeeze everything in their path. And that's where things get even wilder. Every rotation hurls these gravitational waves outward like ripples from a stone tossed into a pond, carrying secrets about black holes we can't learn any other way. When facilities like LIGO and Virgo detect these waves on Earth, they're essentially eavesdropping on the Whirlpool's dance, decoding the universe's hidden language. But here's the puzzle. These black holes are spiraling toward each other, destined to collide in a cataclysm so powerful it would outshine every star in the galaxy. Yet their orbital dance suggests they're stuck in a gravitational stalemate, slowed by gas clouds or dark matter scaffolding we can't yet see. Some theorists argue we're witnessing the final act before merger, a slow, inevitable death spiral. Others propose something even stranger. The black holes might stall indefinitely, trapped in a cosmic limbo by forces we don't yet understand. If that's true, it challenges everything we know about how galaxies evolve. One thing's certain, the Whirlpool's dancing black holes aren't just a spectacle. They're a ticking clock counting down to a collision that will shake the universe and rewrite physics as we know it. Stretching across the Whirlpool Galaxy like a cosmic lasso, an enormous loop of radio waves defies all expectations. A structure so vast it could wrap around our Milky Way multiple times. This mysterious radio loop, detected by some of the world's most sensitive telescopes, emits energy in wavelengths invisible to our eyes but screaming with secrets. It's not tied to any visible feature, no star clusters, no gas clouds, just a ghostly ring hanging in space, pulsing with energy no current theory fully explains. So what could create such a colossal structure? One leading theory points to a galactic collision from billions of years ago. When two galaxies merge, their interwoven magnetic fields can stretch like taffy, creating shock waves that accelerate particles to near light speeds. These particles then spiral along magnetic field lines, emitting radio waves as they go. Imagine dragging a magnet through a pile of iron filings. The chaotic trails left behind might resemble this very loop. But here's the catch. The Whirlpool's last major merger should have been too long ago for such a crisp structure to remain. Unless, of course, we're missing something fundamental about how magnetic echoes persist in galaxies. Then there's the dark horse hypothesis, a runaway black hole. If a middle-sized black hole got slingshotted through the galaxy's disk at incredible speeds, its gravity could have stirred up interstellar gas like a spoon in coffee, leaving behind a turbulent wake that emits radio waves. We've seen similar, though far smaller structures near rogue black holes in other galaxies, but this loop's scale is unprecedented, suggesting either an impossibly fast-moving object or a phenomenon we've never witnessed before. But perhaps the most tantalizing idea involves the galaxy's magnetic skeleton. All spiral galaxies have vast, invisible magnetic fields woven through their arms, but the Whirlpool seems unusually strong and tangled. Some researchers speculate that under just the right conditions, these fields can snap like overstretched rubber bands, releasing energy in enormous loops. It's a cosmic version of what happens during solar flares on our sun, just magnified to galactic proportions. The radio loop enigma isn't just a curiosity, it's a challenge. Every time we think we've mapped the forces shaping galaxies, the Whirlpool throws us a curveball, proving the universe still holds mysteries we've only begun to imagine. Drifting silently between the Whirlpool Galaxy and its smaller companion, vast islands of hydrogen gas float like cosmic ghosts, each one massive enough to birth thousands of stars, yet eerily empty. These aren't just ordinary gas clouds, they're celestial enigmas untethered from any visible structure, glowing faintly in radio wavelengths as if whispering secrets across the void. How did these colossal hydrogen reservoirs end up stranded in intergalactic space, and why haven't they collapsed into stars? The answers might rewrite our understanding of how galaxies interact, or reveal the invisible hand of dark matter itself. One camp of astronomers sees the fingerprints of a violent past. When galaxies collide, tidal forces can rip gas from their spiral arms, flinging it into the abyss like confetti in a hurricane. Simulations show the Whirlpool and its companion, NGC 5195, have danced dangerously close enough for gravity to shred gas clouds into these lonely fragments. But here's the puzzle: these clouds aren't where they should be. They're too far from the galaxy's collision paths, too pristine, lacking the turbulence expected from such a cosmic demolition derby. It's as if someone delicately placed them there, defying the chaos of galactic encounters. That's where the dark matter theorists raise an intriguing alternative. Hydrogen clouds could be cosmic tracers, marking the presence of invisible dark matter halos, clumps of unseen mass that might anchor these gas islands like hidden magnets. If true, each cloud could be a lighthouse illuminating the shadowy architecture of the universe, but proving it isn't easy. Dark matter's gravity should pull the hydrogen into star formation, yet these clouds remain mysteriously dormant, resisting collapse as if some unseen force presses pause on stellar birth. Then there's the wild card, primordial gas. A handful of researchers speculate these clouds might be relics from the universe's infancy, pockets of raw hydrogen untouched by stellar furnaces for billions of years. Finding such pristine gas would be like stumbling upon a vial of unmixed paint from the Big Bang itself, a direct window into the cosmos before galaxies even existed. The ghostly hydrogen clouds aren't just floating curiosities. They're cosmic detectives challenging us to choose between two extraordinary possibilities: the wreckage of a galactic smash-up or the first visible traces of the universe's most elusive substance. Either way, the Whirlpool keeps teaching us a humbling lesson sometimes. The loudest truths come from the quietest corners of space. Tucked within the Whirlpool Galaxy's spiral arms, something extraordinary is unfolding, regions so fiercely productive they make our Milky Way star nurseries look sluggish by comparison. These starburst zones are cosmic factories, churning out new stars at rates up to 10 times faster than anything in our galactic neighborhood. But what's fueling this frenzy of creation? The answer lies in a gravitational tug-of-war with the Whirlpool's smaller neighbor, a dance so disruptive it's reshaping the galaxy from within. Picture two galaxies locked in a slow-motion collision, their gravitational forces stretching and compressing vast clouds of gas like cosmic taffy. As the Whirlpool and its companion, NGC 5195, swing past each other, their mutual pull sends shockwaves through the galaxy's delicate structure. These tidal forces don't just warp the Whirlpool's iconic spiral arms, they trigger chaos in its gas reservoirs, squeezing them until they collapse under their own weight. It's like crumpling a sheet of paper in your hands. The folds and creases become hotspots for star birth, regions where gravity wins out over pressure and gas succumbs to its fate as stellar fuel. But starbursts aren't just about raw materials, they're about timing. The Whirlpool's gas clouds are already richer in heavier elements than those in younger galaxies, packed with the cosmic debris of generations of dead stars. These elements act like catalysts, cooling the gas faster and allowing it to fragment into denser, more fertile pockets. Add the gravitational squeeze from NGC 5195, and you have a perfect recipe for explosive star formation. Yet even this doesn't fully explain the staggering scale of the phenomenon. some starburst regions in the whirlpool defy models, burning brighter and longer than they should. That's where feedback loops come in. Supernova and stellar winds from newly born stars blast surrounding gas, creating shock fronts that trigger yet more collapses. It's a self-perpetuating cycle, star birth leading to star death, which then ignites more star birth. The most mesmerizing part, this frenzy isn't forever. Starbursts are galactic flash floods, brief and intense. Within a few 100 million years, a blink in cosmic time, these zones will exhaust their gas, leaving behind glittering clusters as the only evidence of their fireworks. For now, though, the whirlpool offers front-row seats to one of the universe's most spectacular shows, a galaxy remaking itself in real time. Hidden within the Whirlpool Galaxy's swirling expanse lies a cosmic boundary so strange it defies conventional physics, a region where high-energy particles screech to a halt as if hitting an invisible wall. Cosmic rays, those subatomic bullets racing through space at nearly light speed, approach this zone with tremendous energy, only to vanish abruptly, their signals cutting off like a radio switch to static. Astronomers call it the cosmic ray drop zone, and its existence suggests something extraordinary, an unseen force field operating on scales we've never witnessed before. This isn't just some faint magnetic ripple, it's a barrier powerful enough to stop particles with energies 1 billion times greater than anything produced in Earth's particle accelerators. The strangest part, no known magnetic field in the whirlpool should be strong enough to pull off such a feat. Ordinary galactic magnetism, generated by swirling gas and stars, lacks the punch to halt these ultra-energetic cosmic rays. So what's creating this colossal roadblock in space? One possibility lurks in the shadows, literally. Dark matter, that enigmatic substance making up most of the universe's mass, could be clumped in this region in an unusual configuration. Some theories suggest certain types of dark matter particles might interact weakly with magnetic fields, amplifying them in ways we can't directly observe. If dense knots of dark matter are tangled with the whirlpool's magnetic skeleton, they could generate localized force fields intense enough to deflect even the most energetic particles. Imagine a waterfall hitting an unseen glass ceiling. The water, or in this case, cosmic rays, appears to stop dead for no visible reason. But dark matter isn't the only contender. Another explanation dives into the realm of exotic physics, specifically quantum turbulence in the fabric of spacetime itself. Near supermassive black holes or extreme gravitational environments, space can become foamy, with microscopic twists and turns that act like speed bumps for high-energy particles. The whirlpool's central black hole duo might be churning the surrounding space into such a froth, creating a natural energy filter. It's a radical idea, but if true, it would mean we're glimpsing a previously unknown property of gravity itself. Then there's the wild card, a primordial relic. Some researchers speculate this barrier could be a fossil from the early universe, a remnant of a time when fundamental forces behaved differently. In the first seconds after the Big Bang, phase transitions in spacetime might have left behind defects, cosmic strings or domain walls that now act like invisible fences. If one of these ancient structures intersects the whirlpool, it could explain the sudden particle shutdown without invoking dark matter or modified gravity. What makes this phenomenon so tantalizing isn't just the mystery, it's the implications. If an invisible barrier can halt cosmic rays, what else might it be shielding? Could similar structures hide in other galaxies, subtly shaping how energy flows through the cosmos? The whirlpool's drop zone isn't just a curiosity, it's a potential key to understanding forces that operate silently, yet powerfully across the universe. And that's the beauty of this galaxy. Just when we think we've mapped its wonders, it reveals a boundary we didn't know existed, one that might rewrite the rules of particle physics itself. The Whirlpool Galaxy isn't just a feast for the eyes, it's a mystery radiating in wavelengths far beyond what our eyes can see. astronomers have detected an eerie, persistent glow of gamma rays emanating from its disk, an excess so intense it can't be explained by known cosmic engines like pulsars or supernova remnants. This isn't just background noise, it's a signal, a beacon of high-energy light that hints at something extraordinary happening beneath the galaxy's shimmering surface. Gamma rays are the universe's death rays, photons packing enough punch to strip atoms apart. Normally, they're produced in extreme environments colliding neutron stars, jets from black holes, or the aftermath of supernova. But the Whirlpool's gamma-ray glow is different. It's diffuse, spread across vast swaths of the galaxy rather than pinpointed to specific cataclysms. Imagine turning on a light bulb and seeing the entire room flourish, not just the bulb itself. That's the scale of this enigma. So where's all this energy coming from? One leading suspect is pulsars, rapidly spinning neutron stars that beam radiation like cosmic lighthouses. The Whirlpool's starburst regions are packed with these stellar corpses, and their combined emissions could theoretically add up to something like what we're seeing. But there's a catch. The gamma-ray excess is too smooth, too evenly distributed. Pulsars would create a patchy, uneven glow, flickering like city lights seen from space. This glow, by contrast, is more like a uniform, otherworldly haze. That's where the dark matter hypothesis takes center stage. If dark matter particles, whatever they are, can annihilate or decay upon collision, they might release gamma rays as a byproduct. The Whirlpool's dense core and spiral arms could be teeming with these invisible particles, their interactions lighting up the galaxy in a way ordinary matter never could. It's a tantalizing thought. We might be seeing the first indirect evidence of dark matter's true nature, written in gamma-ray light, but the plot thickens. Some theorists argue this glow could be the signature of something even more exotic, undiscovered particle interactions, processes beyond the standard model of physics. Could there be quantum particles so strange, so fleeting, they only announce themselves in the hearts of galaxies like the Whirlpool? It's a radical idea, but one that grows harder to dismiss as the data piles up. The gamma-ray glow isn't just a scientific puzzle, it's a cosmic whisper, a clue buried in the highest energy light the universe produces, and the Whirlpool, true to form, refuses to make it easy. Every explanation dances on the edge of possibility, teasing us with answers that might rewrite physics itself. One thing's certain, in this galaxy, even the light we can't see holds secrets waiting to be uncovered. Among the Whirlpool Galaxy's most striking features are its dark, ribbon-like dust lanes, those intricate veins of cosmic soot weaving through its spiral arms. But look closely and you'll notice something bizarre. In certain regions, these dusty filaments don't just thin out, they vanish entirely, as if erased by an unseen hand. These aren't gradual fade-outs like mist dissolving in sunlight. They're sharp, jagged edges where dust lanes simply stop, leaving behind gaps as inexplicable as missing puzzle pieces in an otherwise complete picture. Dust lanes are supposed to be resilient, made of carbon, silicon, and other heavy elements forged in stellar furnaces. They typically endure for millions of years, drifting lazily through interstellar space. So what could scour them away so abruptly? One leading theory points to radiation pressure, the sheer force of starlight itself. Near the Whirlpool's frenzied starburst regions, young, massive stars burn blisteringly bright, their ultraviolet radiation acting like cosmic sandblasters. Photons strike dust grains, pushing them outward with enough force to overcome gravity's grip. Over time, this relentless pressure could clear entire corridors, leaving behind these puzzling voids. Yet there's a problem with that explanation. While radiation can disperse dust, it usually does so unevenly, creating wispy tendrils rather than hard edges. That's where interstellar winds enter the picture. The Whirlpool's supernova factory isn't just producing light, it's generating shockwaves. Each dying star hurls material outward at thousands of kilometers per second, creating gales powerful enough to sweep dust lanes clean. Combine multiple supernova in a tight cluster, and you've got a hurricane force broom scrubbing the galaxy's dusty floor. But the plot thickens. Some of these dust-free zones appear nowhere near star-forming regions, defying the radiation and winds narrative. That's prompted researchers to consider a far more exotic culprit: magnetic upheaval. The Whirlpool's magnetic fields, twisted by its dance with its companion galaxy, might occasionally snap like overstretched rubber bands, releasing bursts of energy that ionize dust particles, effectively vaporizing them in localized pockets. Picture a lightning bolt striking a sandy beach. Where it hits, the sand fuses into glass. On a galactic scale, magnetic reconnection could do something similar, leaving behind bizarre, dust-free patches. Then there's the wildcard theory: dark matter interactions. If certain types of dark matter particles collide and annihilate, they could produce bursts of energy capable of disrupting dust clouds. While speculative, the idea gains traction from the fact that some of the Whirlpool's dust gaps align eerily with predicted dark matter clumps. It's a long shot, but in a galaxy that constantly defies expectations, even the most far-fetched ideas deserve a hearing. What makes these disappearing dust lanes so compelling isn't just the mystery of their absence, it's what they reveal about the invisible forces sculpting galaxies. Every gap is a fossil record, preserving the aftermath of events we can't directly see. Stellar winds howling across millennia, magnetic storms raging in the void, or perhaps something even stranger. The Whirlpool doesn't just hide its secrets in shadow. Sometimes it's the absence of shadow that speaks loudest. Stretching like a celestial tightrope across the Whirlpool Galaxy, an impossibly straight line of star clusters cuts through the chaos, a formation so precise it looks artificial. This thousand-light-year-long structure, dubbed the celestial string, defies the natural curves and swirls we expect from galaxies. Instead of following the Whirlpool's elegant spiral arms, these stars align with geometric perfection, as if drawn by a cosmic ruler. The strangest part: such linear arrangement shouldn't exist in nature without a visible cause, yet here it is, glowing defiantly against the dark canvas of space. One explanation points to tidal forces, the gravitational tug-of-war between the Whirlpool and its smaller companion galaxy. When galaxies interact, they can stretch each other's stars and gas into long, thin streams called tidal filaments. Picture pulling taffy until it forms delicate strands. The same principle might apply here, with gravity sculpting this stellar necklace over eons. But there's a problem. Tidal filaments are typically chaotic, curving like spider silk caught in the wind. The celestial string's razor-straight edges and uniform spacing suggest something far more precise, almost as if an unseen hand guided its formation. That's where the more radical theories take root. Could this be evidence of directed energy, a beam of unimaginable power carving a path through interstellar gas, leaving behind a trail of newborn stars? On Earth, lasers can etch perfect lines into materials. On a galactic scale, could a similar process be at work? Some researchers speculate that jets from supermassive black holes, firing with pinpoint accuracy for millions of years, might have ionized gas along this corridor, triggering star formation in a perfectly straight line. It's a staggering idea: black holes not just as destroyers but as cosmic sculptors, shaping galaxies with their energy. Yet even that doesn't fully explain the string's eerie regularity. The spacing between clusters is too even, the alignment too flawless. That's led to whispers of an even wilder possibility: resonant harmonics in the galaxy's magnetic field. Just as a plucked guitar string vibrates at specific frequencies, magnetic field lines might, under extreme conditions, create nodes of instability where gas collapses into stars, like beads on an invisible wire. If true, the celestial string wouldn't just be a curiosity, it'd be a living experiment in how magnetism shapes the universe. The truth might lie somewhere between these ideas or beyond them entirely. What makes this structure so captivating isn't just its mystery, but what it reveals about the Whirlpool's turbulent history. Every perfectly placed cluster is a clue, one that could rewrite our understanding of how galaxies evolve or even hint at forces we've yet to imagine. In a universe where chaos reigns, the celestial string stands as a defiant exception, challenging us to rethink the boundaries of the possible. Buried near the Whirlpool Galaxy's outer edges, a cosmic strobe light pulses with no discernible rhythm, a quasar so unpredictable it flickers like a candle in a storm. This isn't just any active galactic nucleus. It's a celestial enigma that brightens and dims by factors of 10 within weeks, sometimes even days, defying the steady glow typical of these supermassive black hole powerhouses. Quasars are supposed to be the universe's most reliable beacons, their brilliance fueled by matter spiraling into black holes at nearly light speed. The process normally creates a stable, blazing accretion disk. Think of a whirlpool of superheated gas shining with the light of a trillion stars. But this one, it's more like a faulty light bulb flickering in ways that leave astrophysicists scrambling for explanations. One leading theory points to microlensing, an eerie cosmic illusion where invisible objects magnify the quasar's light like a funhouse mirror. If a rogue star, black hole, or dense dark matter clump drifts between us and the quasar, its gravity could bend light rays, amplifying them unpredictably as it moves. It's akin to someone randomly adjusting a telescope's focus dial from afar, making the quasar appear to brighten and fade without actually changing. The Whirlpool's crowded galactic environment makes this scenario plausible. Its halo could be littered with such unseen lensing objects. Yet microlensing alone struggles to explain the quasar's sharpest fluctuations. Some brightness changes occur too abruptly, as if a switch were flipped inside the accretion disk itself. That's where the accretion instability hypothesis takes over. Imagine the disk not as a smooth, glowing platter but as a storm-tossed sea, with clumps of gas collapsing chaotically into the black hole. Magnetic turbulence or quantum effects near the event horizon might trigger avalanches of matter, each dump creating a violent flare followed by a lull. Recent simulations suggest these instabilities could cascade like dominoes, producing the observed erratic flickering. Then there's the curveball, a second black hole. If the quasar hosts not one but two supermassive black holes locked in a tight orbit, their gravitational tugs could warp the accretion disk into lopsided, unstable configurations. As they whirl around each other, one might periodically steal matter from the other's disk, creating bursts of feeding frenzy followed by starvation, a cosmic version of musical chairs played with stellar gas. What makes this flickering quasar so compelling isn't just the mystery, it's the opportunity. Each unpredictable pulse carries clues about black hole physics under extreme conditions, offering a natural laboratory we could never replicate on Earth. And in true Whirlpool fashion, it refuses to conform to expectations, reminding us that even the brightest cosmic giants can harbor the strangest secrets. In the heart of one of the Whirlpool Galaxy's spiral arms, an ominous void churns not a mere absence of light, but a swirling abyss where interstellar gas spirals inward as if down a cosmic drain. This isn't just a gap in the celestial canvas, it's a dark vortex, a maelstrom of nothingness stretching hundreds of light years across, its edges crisp against the glowing backdrop of stars. Unlike typical black holes, which announce their presence with blazing accretion disks, this vortex is eerily quiet, a silent whirlpool devouring matter without the usual fanfare of radiation. What could carve such a perfect void into the galaxy's fabric? One spine-chilling possibility is a rogue intermediate mass black hole too small to dominate the galactic core, yet too massive to wander unnoticed. These elusive objects, theorized but rarely observed, might drift unseen through the whirlpool's arms, their gravity funneling surrounding gas into invisible eddies. Picture a stealth submarine gliding through ocean depths, its wake the only betrayal of its presence. If such a black hole plowed through this region, it could have swept up gas like a cosmic vacuum, leaving behind this eerie, swirling scar. Yet the vortex's razor-sharp edges suggest something even stranger. Ordinary gravitational interactions tend to be messy, distorting gas clouds into wispy tendrils, not perfect spirals. That's where space-time distortions enter the picture. Certain exotic physics models predict that extreme gravitational fields can twist the fabric of reality itself, creating stable vortices where space literally folds inward. Imagine stirring honey with a spoon. The liquid curls into a temporary funnel. Now scale that up to galactic proportions, with space-time as the honey and an unseen cosmic force as the spoon. Then there's the wild card, dark matter hurricanes. If dark matter, that invisible scaffold of the universe, clumps in dense, rotating formations, its gravity could sculpt gas into these unnatural whirlpools without emitting a single photon. It's a ghostly hand shaping the galaxy from the shadows, invisible yet undeniable in its effects. The dark vortex isn't just a curiosity, it's a challenge to our understanding of gravity itself. Whether it's a wandering black hole, a kink in space-time, or the fingerprint of dark matter, one thing's certain: in the Whirlpool Galaxy, even emptiness tells a story. And this particular void, it's screaming that we've barely scratched the surface of how the universe truly works. Tucked within the Whirlpool Galaxy's spiral arms, an invisible inferno rages, a blistering hotspot glowing fiercely in infrared light yet utterly absent in visible wavelengths. This mysterious anomaly, detected by space telescopes like Spitzer and James Webb, pulses with the warmth of a cosmic furnace, radiating heat equivalent to hundreds of suns. But point an optical telescope at its coordinates, and you'll find only darkness. It's as if the universe flipped a switch, allowing us to sense the heat but not the source. So what's cooking in this hidden corner of the galaxy? One compelling explanation lies buried beneath thick veils of cosmic dust. Starburst regions, where new stars ignite within dense gas clouds, often shroud themselves in such opaque cocoons, visible only in infrared as the dust absorbs their light and re-emits it as heat. The whirlpool's frenetic star-forming activity makes this a strong contender. Imagine a neon sign wrapped in black velvet. The fabric swallows the visible glow, but warmth still seeps through. In this case, the fabric could be dust lanes so thick they've smothered an entire stellar nursery from view, leaving only its thermal fingerprint. Yet the anomaly's temperature profile tells a stranger story. Typical dust-obscured star clusters emit diffuse infrared signatures, while this hotspot shows a sharp, almost point-like intensity, more like a single superheated object than a scattered nursery. That's led researchers to ponder alternative scenarios, including the ghostly echoes of a long-dead star. When a supernova explodes, its shockwave can heat surrounding dust for centuries, creating lingering infrared afterglows. If a massive star met its end here millennia ago, its final blast might still be writing its epitaph in thermal radiation, like a flashbulb's afterimage burned into the galaxy's retinas. The plot thickens when considering the hotspot's location far from any known supernova remnants or active star-forming zones. This isolation has spurred more exotic theories, like the presence of a dust-enshrouded microquasar, a stellar mass black hole gorging on a companion star while buried under an avalanche of debris. Such objects can generate tremendous heat as matter spirals inward, but if the dust shell is thick enough, only the infrared glow escapes. Picture a blast furnace sealed behind brick walls. You'd feel the heat long before seeing flames. Then there's the most tantalizing possibility, a cosmic fossil. Some astronomers suggest this could be the thermal remnant of a runaway black hole's ancient feeding frenzy. If a middling black hole plowed through a gas cloud eons ago, its gravitational pull might have triggered a short-lived burst of heating before moving on, leaving behind this infrared relic like a cooling ember from a forgotten fire. What makes this anomaly so captivating isn't just its invisibility in optical light, it's the reminder that galaxies hide their most dramatic stories in plain sight, written in wavelengths our eyes can't see. The Whirlpool's infrared secret whispers that for every shining star we admire, there may be a dozen more, cloaked in darkness, waiting to be felt rather than seen. And that's the magic of this galaxy. It doesn't just dazzle us with beauty, it teaches us to look beyond the light. Stretching nearly perpendicular to the Whirlpool Galaxy's iconic spiral disk, a faint band of stars and gas appears to encircle its poles like a cosmic hula hoop, a feature so rare it's only been spotted in a handful of galaxies across the observable universe. Polar rings, as these structures are known, typically form during violent galactic collisions, when a smaller galaxy gets shredded and its debris flung into orbit around the larger one's poles. But here's the twist: the Whirlpool shows no obvious scars of such a catastrophic encounter. So is this ring real or just a trick of perspective? The evidence is tantalizing but messy. Deep field images reveal a delicate arc of hydrogen gas and dim stars arcing over the galaxy's north pole, seemingly detached from the main disk. Spectroscopy confirms this material moves at right angles to the Whirlpool's rotation, exactly as you'd expect from a genuine polar ring. Yet there's no sign of the dense central hub typically seen in classic polar ring galaxies, no clump of stars marking the corpse of the devoured satellite. It's more like a ghostly belt than a full ring, raising doubts about its origins. One camp argues we're seeing the aftermath of a galactic heist. The Whirlpool's gravitational dance with its smaller companion, NGC 5195, could have siphoned gas from the dwarf galaxy over eons, stretching the stolen material into this tenuous loop. Computer simulations show such slow-motion theft can create partial rings without the violence of a full merger, like pulling taffy rather than smashing a pie. But skeptics counter that the ring's composition doesn't quite match NGC 5195's chemical fingerprint, leaving the mystery of its donor unsolved. Then there's the illusion hypothesis. Some researchers propose the ring might actually be a warped outer arm of the Whirlpool itself, bent perpendicular by tidal forces during a close galactic encounter. Picture a vinyl record left too close to a heater. Its edge warps upward, creating the illusion of a separate structure when viewed from the side. If true, this would make the Whirlpool's polar ring a cosmic mirage, one that challenges our ability to interpret two-dimensional images of three-dimensional objects millions of light years away. The most intriguing clue comes from dark matter. Polar rings serve as natural probes for a galaxy's invisible gravitational scaffolding, their orbits tracing the shape of the underlying halo. The Whirlpool's possible ring suggests its dark matter might be oddly flattened like a squashed beach ball, an arrangement that defies standard models of halo formation. Could this explain the ring's patchiness, or is dark matter's grip subtly shepherding gas into this peculiar configuration over eons? Every observation deepens the puzzle. Hubble's sharp eyes reveal young blue stars peppering the ring's edges, proof it's fertile ground for starbirth, not just ancient debris. Yet ALMA radio telescopes detect no dense gas clouds, the raw material needed to form such stars. It's as if the ring is both fertile and barren at once, a paradox wrapped in celestial ribbons. Whether optical illusion or cosmic rarity, the Whirlpool's polar ring reminds us that galaxies aren't flat caricatures. They're dynamic, three-dimensional puzzles where perspective shapes perception. And in this case, the truth might be hiding in plain sight, waiting for the right angle of light or the right theory to bring it into focus. Deep within the Whirlpool Galaxy, the past refuses to stay silent. Ghostly afterimages of long-dead stars flicker back to life centuries after their demise, thanks to a mesmerizing cosmic trick called light echoes. Picture a supernova exploding with the brilliance of a billion suns, its light radiating outward in all directions. While some photons race straight toward Earth, others take a detour, bouncing off vast interstellar dust clouds before finally reaching our telescopes decades or even centuries later. The result, a celestial time machine where the same stellar catastrophe appears multiple times across the sky, like a cosmic echo bouncing between canyon walls. These light echoes aren't just pretty illusions, they're cosmic cartographers, helping astronomers map the galaxy's hidden architecture. Each delayed flash carries a secret. Its path reveals the location of otherwise invisible dust clouds. By tracking multiple echoes from a single supernova, scientists can triangulate the 3D positions of these scattering structures, building a skeleton map of the Whirlpool's interstellar medium. It's like watching lightning illuminate the outline of a mountain range at night. Each flash exposes new contours of the unseen landscape. But the real magic lies in the echo's time-traveling nature. In 2007, astronomers witnessed a light echo from a supernova that likely detonated around the time Galileo first pointed his telescope at the stars. The light traveled straight to Earth for 400 years, then another beam, having ricocheted off a dust cloud halfway across the galaxy, arrived just in time for modern telescopes to catch it. Suddenly, the same explosion could be studied twice, once in its raw, unfiltered glory, and again centuries later, its light altered by its interstellar detour. These echoes also expose the dust cloud's composition. As light bounces off microscopic silicate and carbon grains, specific wavelengths get absorbed, leaving spectral fingerprints in the reflected beam. It's forensic astronomy, the equivalent of dusting for cosmic fingerprints at a crime scene. Some echoes even hint at bizarre dust properties, like fractal-shaped grains or magnetic alignments we've never seen in our own galaxy. Perhaps most hauntingly, light echoes reveal how little of the Whirlpool we truly see. For every supernova visible directly, there may be dozens of unseen explosions whose light is still en route, or trapped forever in labyrinthine dust lanes, their echoes doomed to wander the galaxy like cosmic ghosts. Every flash from the past is a reminder. The Whirlpool story isn't written in light alone, but in the shadows it leaves behind. From the depths of the Whirlpool Galaxy, an eerie rhythm pulses across the cosmos, radio waves ticking with clockwork precision every 22 minutes, like a metronome set by celestial hands. Astronomers first dismissed it as interference, a glitch in their instruments, but when multiple telescopes confirmed the signal's reality, a chilling truth emerged. Something out there is whistling in the dark, and its tune defies easy explanation. This cosmic whistle isn't just regular, it's relentless, unlike pulsars which flicker milliseconds apart or magnetars that erupt unpredictably. This source maintains its 22-minute cadence with atomic clock accuracy. Each burst lasts exactly 90 seconds, blasting radio waves across the universe before vanishing into silence, only to reappear right on schedule. It's as if the galaxy itself is tapping out Morse code, but the message remains encrypted. Natural explanations point to ultra-long, period magnetars, neutron stars with magnetic fields so strong they warp the very atoms on their surfaces. Normally, magnetars spin rapidly, their radio pulses arriving in quick succession. But theorists suggest one with an unusually sluggish rotation could explain the whistle's languid rhythm. Picture a lighthouse whose beam sweeps by not every few seconds but once a generation. The physics checks out mostly. There's just one wrinkle: magnetars this slow should have faded eons ago, their magnetic fields drained by time. Yet this one sings on, defiantly youthful in a universe that should have silenced it. That inconsistency has fueled more speculative fires. Could this be a technosignature, an artificial beacon deliberately engineered to stand out against nature's background noise? The 22-minute interval is tantalizingly deliberate, far longer than any known natural source, yet short enough to suggest intentional design. Some researchers even note its frequency resembles proposed hailing signals from old SETI studies, hypothetical greetings meant to catch the attention of emerging civilizations. Then there's the middle ground, a natural phenomenon we've yet to imagine. Just as pulsars baffled scientists until they were recognized as spinning neutron stars, the cosmic whistle might represent a new class of object, one that operates on principles outside our textbooks. Perhaps it's a magnet wrapped in a debris disk, its rotation braked by cosmic friction, or a binary system where one dead star's gravity periodically triggers radio bursts from its partner. What makes this signal so captivating isn't just its mystery, it's its persistence. While other cosmic oddities flicker and fade, the whistle endures, a rhythmic heartbeat in the whirlpool's chest. Whether it's the gasp of a dying star or the greeting of a distant mind, one thing's clear: the universe is still teaching us how to listen. Among the Whirlpool Galaxy's most mind-bending tricks is its ability to twist the fabric of reality itself, acting as a colossal gravitational lens that distorts and duplicates the light of galaxies far beyond it. When astronomers peer toward M51, they've spotted something uncanny: smeared arcs and ghostly copies of background galaxies stretched like taffy around its edges. This isn't a glitch in the telescope, it's Einstein's theory of relativity in action, proving that even light can't escape the warping power of gravity. At the heart of this cosmic illusion lies a simple yet profound principle: mass bends space. The whirlpool's immense gravitational pull, fueled by stars, gas, and invisible dark matter, acts like a funhouse mirror, curving the path of light from galaxies billions of light-years behind it. The result: a single distant galaxy might appear multiple times around the whirlpool's halo, its image split and magnified like a candle's flame reflected in a shattered mirror. These gravitational mirages aren't just cosmic curiosities. They're tape measures for the invisible, allowing scientists to weigh the whirlpool in a way no ordinary telescope could. Here's how it works. By tracking how severely background galaxies are distorted, astronomers can map the distribution of mass in the whirlpool, including the dark matter that makes up most of its bulk. The more stretched and duplicated the images appear, the stronger the lensing effect, revealing where dark matter clumps most densely. It's like watching someone press their fingers into a stretched bed sheet. You can't see the fingers, but their imprint betrays their presence. But the revelations don't stop there. Some lensed galaxies appear brighter than they should, magnified by the whirlpool's gravity like a natural telescope. This accidental zoom lens gives astronomers a free upgrade, letting them study galaxies so distant they'd normally be invisible to our instruments. Imagine stumbling upon a cosmic magnifying glass that just happens to focus on the universe's earliest epochs. That's the serendipity of gravitational lensing. Yet the whirlpool's lensing effect has thrown some curveballs. Certain background galaxies appear oddly positioned, their light bent more sharply than the visible matter alone can explain. This discrepancy points to dark matter's hidden scaffolding structures so vast and diffuse they escape detection by any other means. Some patches of the whirlpool's outskirts seem to grip space with unseen hands, warping light far beyond what its stars and gas should account for. Even more intriguing are the failed mirages, regions where lensing should occur based on the whirlpool's visible mass but doesn't. These silent patches might be voids in the dark matter web, bubble-like pockets where the universe's mysterious skeleton is oddly sparse. It's as if the galaxy's hidden framework has holes, gaps that light slips through undisturbed. Every distorted image, every stretched arc around the whirlpool is a coded message, one that's helping astronomers decode the universe's darkest secret. And in true M51 fashion, it's not just showing us the answers, it's teaching us how to ask better questions. Woven through the Whirlpool Galaxy's spiral arms, an invisible force contorts space itself, magnetic fields so violently twisted they resemble cosmic tornadoes. These aren't the orderly lines we see around planets or stars. They're chaotic tendrils writhing like snakes caught in a hurricane, their intensity defying every model of how galactic magnetism should behave. Normally, a galaxy's magnetic field follows its rotation, stretching into elegant spirals as stars and gas orbit the center. But the whirlpool, its fields kink, tangle, and occasionally snap like overstretched rubber bands, unleashing bursts of energy that leave theorists scrambling for explanations. What makes these magnetic monstrosities so baffling is their sheer strength. According to dynamo theory, the leading framework for how cosmic magnetism arises, galactic fields should be weak, diffuse things, generated slowly by the churning of ionized gas over billions of years. But the Whirlpool's fields pack a punch comparable to those around active black holes, with energies that shouldn't exist in a tranquil spiral galaxy. Some regions even exhibit magnetic loops large enough to encircle entire star clusters, their origins as mysterious as their scale. One clue lies in the Whirlpool's turbulent relationship with its smaller neighbor. As the two galaxies graze each other, their gravitational dance sends shockwaves through the interstellar medium, stirring plasma like a spoon in a cup of swirling coffee. This chaos could amplify magnetic fields through a process called turbulent dynamo, where random motions twist and stretch magnetic lines, pumping energy into them like winding a jack in the box. But simulations show this mechanism alone can't account for the Whirlpool's extreme contortions. There's something else at work, something hidden in the spaces between stars. That's where intergalactic plasma currents enter the picture. The Whirlpool floats in a sea of superheated gas, part of a vast filamentary web stretching between galaxies. Recent radio observations reveal tendrils of this plasma piercing the galaxy's disk like invisible lightning bolts, potentially injecting external magnetic energy directly into its spiral arms. Imagine tossing a handful of magnets into a vat of molten iron. Their fields would warp and braid in unpredictable ways. Now scale that up to galactic proportions, and you've got a possible recipe for the Whirlpool's magnetic mayhem. Yet the most tantalizing hypothesis involves dark matter's hidden hand. If certain dark matter particles interact weakly with magnetic fields, a controversial idea gaining traction, their invisible bulk could be twisting the galaxy's magnetism from within. Picture a river's current bending around submerged rocks. If dark matter clumps act like those unseen obstacles, they might redirect magnetic lines into these bizarre configurations. The Whirlpool's magnetic chaos isn't just a local oddity, it's a window into forces shaping every galaxy. Every kink and snap challenges our assumptions, reminding us that the universe's rulebook is far from complete. And in this galactic whirlpool, even the invisible has its own violent storms. In the swirling depths of the Whirlpool Galaxy, stars are playing an interstellar game of hide and seek, except some never reappear. Astronomers have catalogued dozens of cases where luminous suns, some thousands of times brighter than our own, simply blink out of existence without the fanfare of a supernova or the telltale swirl of a black hole's feast. These aren't dimming events or temporary eclipses. These stars leave behind empty patches of sky where their light once blazed, as if erased from the cosmic ledger. Take the case of N6946BH1, a red supergiant monitored for years in the Whirlpool's neighboring galaxy. In 2009, it flared briefly to 50 times its normal brightness, then vanished without a trace. No explosion, no remnant, just darkness. The leading explanation, a failed supernova. Some massive stars, theorists suggest, might collapse directly into black holes without the usual fireworks, their outer layers imploding so completely that not even a light echo remains. It's the cosmic equivalent of a building demolition where the structure doesn't topple, it just folds inward silently, leaving an empty lot. But not all disappearances fit this mold. Other stars in M51 have faded gradually over decades, their light bleeding away like sand through an hourglass. These cases spur wilder theories, like the possibility of rogue black holes drifting unseen through the galactic disk. If a wandering intermediate mass black hole passed near a star, its gravity could siphon off the star's outer layers slowly, dimming it to invisibility without the violent disruption expected from a direct collision. Imagine a vampire starved into shadows by an invisible predator. Then there's the most speculative idea, one that straddles the line between astrophysics and science fiction. Could some of these vanishing acts be evidence of advanced civilizations? The concept of Dyson spheres, hypothetical megastructures built around stars to harness their energy, predict stars dimming as their light is captured and repurposed. While there's no direct proof, the Whirlpool stellar dropouts sometimes match the predicted signatures of such engineering: sudden, non-catastrophic dimming across all wavelengths. Skeptics rightly point out simpler explanations like dust clouds or instrumental errors, but the pattern persists just enough to keep the debate alive. What makes these disappearances so unnerving is their silence. The universe is rarely subtle. Stars die in spectacular explosions, collide with blinding flashes, or get shredded into glowing streams by black holes. But they slip away like ghosts, leaving behind only questions and the chilling realization that even the brightest giants can vanish without a trace. In the Whirlpool Galaxy, the rules of stellar life and death might be stranger than we ever imagined. Scattered like celestial cannonballs across the Whirlpool Galaxy's outskirts, brilliant blue stars streak through the void at impossible speeds, stellar fugitives fleeing their birthplace with velocities that defy gravity's grasp. These aren't just wandering suns, they're hypervelocity outliers, some racing at over 3 million kilometers per hour, their paths tracing invisible scars from ancient cosmic violence. What could fling a star fast enough to escape a galaxy's clutches? The leading suspect, the supermassive black hole duo at the Whirlpool's heart. When a binary star system wanders too close to these gravitational titans, one star might get captured while the other is slingshotted outward like a stone from a trebuchet. The math is chillingly precise, a carefully choreographed dance where gravity's pull becomes a catapult, converting orbital energy into sheer, unrelenting speed. But here's the twist: some of these blue outliers trace back to regions far from the galactic center, where no black hole's reach could explain their escape velocity. That's where the hidden architects emerge. By reverse engineering these stars' trajectories, astronomers have mapped them to dense star clusters in the Whirlpool's spiral arms, regions where stellar densities rival a Tokyo subway at rush hour. In such crowded quarters, gravitational pinball is inevitable. Picture a star flung from a chaotic game of cosmic bumper cars, where close encounters with massive neighbors can boot it into the galactic abyss. Simulations show these cluster ejections often leave behind distinctive fingerprints, paired outliers, two stars hurled in opposite directions like fragments from an exploding grenade. Yet the plot thickens. A handful of these blue runners show chemical signatures unlike anything in the Whirlpool's current stellar population: higher concentrations of helium, bizarre isotopic ratios, even traces of elements typically forged only in the universe's first generation of stars. This raises a spine-tingling possibility. Some outliers might be intergalactic immigrants, stolen from the Whirlpool satellite galaxies during close passes and then ejected like unwanted hitchhikers. Their paths become cosmic breadcrumbs, leading back to long-forgotten galactic encounters written in starlight and velocity. The real revelation lies in what these streaking blue giants reveal about the unseen. Every curved trajectory, every unexpected slowdown or acceleration hints at the gravitational topography of the Whirlpool's dark matter halo. The way its invisible mass tugs at these stellar escapees like hidden magnets. Some paths wiggle suspiciously, suggesting close brushes with dark matter clumps too diffused to detect any other way. Others arc smoothly, tracing the grand contours of the galaxy's gravitational field like iron filings aligning to a magnet shape. These blue outliers aren't just runaway stars. They're probes, nature's own deep space missions charting the Whirlpool's hidden architecture. And with every new hypervelocity discovery, we're handed another piece of the puzzle, one that might finally explain how galaxies keep their stars in line and what it takes to break free. In the heart of the Whirlpool Galaxy's grand design, astronomers have stumbled upon a cosmic vacuum cleaner's dream, a pristine void spanning 500 light-years where stardust simply doesn't exist. Unlike typical interstellar gaps where dust merely thins, this region is clinically clean, as if some unseen force meticulously scrubbed every grain of cosmic soot from the area. The absence is so absolute it glows conspicuously in infrared surveys, appearing as a dark fingerprint against the galaxy's dusty canvas. What could erase dust on such a colossal scale? The prime suspect is a supernova shockwave of unimaginable power. When massive stars detonate, their death throes unleash supersonic blasts that sweep up surrounding material like a cosmic bulldozer. Picture a bomb detonating in a sandstorm. The initial flash might vaporize nearby grains, while the shockwave flings the rest into distant drifts. The Whirlpool's frenzied star-forming regions make this scenario plausible. Multiple supernovae could have stacked their shockwaves over millennia, creating overlapping clean zones that merged into this vast emptiness. But there's a wrinkle. Supernova-cleared regions usually leave behind telltale signatures: heated gas shells, swirling turbulence, or at least a central neutron star as a graffiti tag marking the explosion's epicenter. This void shows none of that. It's eerily tranquil, more like a surgical excision than a natural clearing. That's led some researchers to ponder whether something more exotic is at work. Could a passing black hole have vacuumed up the dust? Intermediate mass black holes, those elusive middleweight predators, might prowl the galaxy's spiral arms, their gravity funneling nearby material into invisible vortices. Yet even they would leave gravitational ripples or X-ray echoes, clues conspicuously absent here. Then there's the wildcard theory, one that straddles astrophysics and speculative futurism. What if this isn't a natural phenomenon at all? The void's crisp boundaries and lack of residual heat resemble predictions for hypothetical Birkeland pumps, devices theorized by advanced civilizations to clear dust for energy collection or navigation. While invoking alien megastructures is a last resort in scientific discourse, the Whirlpool's dustless zone checks unsettlingly specific boxes, a region too clean for known physics, yet too perfectly shaped for random cosmic processes. Yet perhaps the most elegant explanation lies in magnetism. The Whirlpool's twisted magnetic fields, some of the most violent ever observed, could be acting like cosmic particle accelerators, charging dust grains until they repel each other into exile. If magnetic forces aligned just right, they might have corralled dust into surrounding lanes over millions of years, leaving behind this unnatural-looking clearing, a celestial version of how a magnet sorts iron filings into neat lines. Whether it's the echo of ancient stellar cataclysms, the shadow of a hidden black hole, or something beyond our current imagination, this dustless void serves as a humbling reminder. Even in something as mundane as missing dirt, the Whirlpool Galaxy finds ways to astonish us, proving that the universe's most ordinary absences can hold extraordinary secrets. Deep within the Whirlpool Galaxy's core, one of its dueling black holes fires a beam of plasma so fast it appears to break the universe's ultimate speed limit, a relativistic jet that seems to outpace light itself. This isn't science fiction bending the rules. It's a cosmic magic trick played by the laws of physics, where perception and reality collide in a dazzling display of Einstein's relativity. When astronomers first tracked this jet's motion, they measured its apparent speed at nearly 7 times the speed of light, a blatant violation of everything we know about cosmic velocity caps. But here's the twist: nothing's actually breaking the rules. The illusion comes from the jet's angle and its terrifying velocity, a hair's breadth below true light speed. If you've ever watched a plane skim across the sky at sunset, appearing to crawl while actually moving hundreds of kilometers per hour, you've witnessed a similar effect. The black hole's jet, racing toward us at a slight angle, has its light stretched and compressed by relativistic effects, warping our perception of time and distance. Here's how the trick works. As the jet's plasma surges forward at 0.999 times light speed, each new burst of light it emits has less distance to travel to reach us than the light emitted moments before. Our telescopes see these signals arriving in rapid succession, like a cosmic sleight of hand where the jet's apparent motion seems to outrun its own light. It's the universe's version of a strobe light at a dance club, where timing and perspective turn normal movement into something surreal. But the real magic lies in what this illusion reveals. The jet's exaggerated speed helps astronomers measure its true velocity with precision, confirming it's one of the fastest outflows ever observed. Each twisted knot of plasma acts like a breadcrumb trail, mapping the black holes feeding frenzy in real time. And because the jet's material originates terrifyingly close to the event horizon, studying its apparent superluminal dance offers a backdoor glimpse into gravity's strongest grip, a place where time slows to a crawl and space itself turns fluid. The Whirlpool's time-delayed jet isn't just a curiosity. It's a masterclass in relativity's most counterintuitive predictions, proving that even when the universe seems to cheat, it's actually teaching us the rules more deeply. And in a galaxy already brimming with wonders, this cosmic mirage stands out not for breaking physics, but for revealing how much stranger reality truly is. Lurking within the Whirlpool Galaxy's chaotic spiral arms, colossal nurseries of gas and dust defy the odds, giant molecular clouds that, by all rights, should have been torn apart eons ago. These sprawling structures, some spanning hundreds of light years, are cosmic cradles where stars are born, their fragile tendrils of hydrogen and carbon monoxide clinging together against a backdrop of gravitational chaos. What's astonishing isn't just their size, it's their resilience. The Whirlpool's environment is a gauntlet of supernova shockwaves, raking tidal forces and searing radiation from newborn stars. Yet these clouds endure unshaken, as if woven from some invisible thread holding the universe itself together. The secret to their survival might lie in a force we can't even see: magnetic fields. Picture a spiderweb stretched across a hurricane it shouldn't hold, yet if the strands are strong enough, they might just weather the storm. That's the idea behind magnetic stabilization. Galactic magnetic fields, though invisible, thread through these molecular giants like cosmic rebar, their tension counteracting the violence of the Whirlpool's surroundings. Charged particles within the clouds spiral along these magnetic lines, creating a scaffold that resists collapse. It's not just gas and dust, it's gas and dust armed, its structure reinforced by an unseen magnetic skeleton. But there's a catch. The Whirlpool's magnetic fields are notoriously chaotic, twisted into knots by galactic collisions and star-forming frenzy. Normally, such turbulence should shred molecular clouds, not preserve them. That discrepancy has led researchers to an even wilder idea. Perhaps these clouds aren't passive victims of their environment, but active participants in their own survival. Observations reveal some clouds exhibit bizarre internal motions, gas streams flowing in organized patterns as if choreographed. This isn't random churn. It's structured turbulence, a self-regulating dance where energy dissipates evenly, preventing catastrophic collapse. Think of a pot of boiling water with a spoon stirring it gently. The heat spreads rather than erupting. The real enigma: some of these clouds appear too pristine. Their chemical makeup lacks the expected pollution from supernova debris, suggesting they've somehow avoided the Whirlpool's violent history altogether. One radical theory proposes they're not native to the galaxy, they're interlopers captured during a long-ago galactic heist. As the Whirlpool and its companion galaxy grazed past each other, their gravitational tug of war might have ripped entire molecular complexes from one disk and flung them into the other, where they now drift like celestial icebergs, resisting melting in an alien sea. Yet the most tantalizing clue comes from their shadows. When background starlight filters through these clouds, it carries spectral fingerprints of molecules we've barely catalogued: exotic compounds clinging to dust grains, their bonds stabilized by magnetic fields. Some of these molecules shouldn't survive the Whirlpool's radiation bath unless shielded by forces beyond standard physics. That's where dark matter whispers again. If certain dark matter particles interact weakly with magnetic fields, their presence could amplify the cloud's stability, acting as invisible armor against dissolution. These molecular clouds aren't just surviving the whirlpool's chaos, they're thriving within it, sculpting the galaxy's future one newborn star at a time. And their defiance teaches us something profound. Even in the universe's most violent neighborhoods, nature finds a way to weave order from the storm. At the very heart of the Whirlpool Galaxy, where logic says everything should move in perfect harmony, astronomers have stumbled upon a cosmic rebellion, a core spinning defiantly in the wrong direction. While the rest of the galaxy whirls like a graceful pirouette, this central region rotates backward, as if some unseen hand reached in and twisted the cosmic knob the opposite way. This isn't just a slight misalignment, it's a full-blown counter-rotation, a celestial dance where partners move in opposite steps. So how does a galaxy's heart break its own rhythm? The leading theory points to a violent galactic merger billions of years ago. Picture two galaxies colliding in slow motion, their stars passing like ghosts through the night, but their cores locked in a gravitational tug of war. If the incoming galaxy struck at just the right angle, its spinning core could have transferred its momentum to the whirlpool's center, essentially winding it backward like a twisted rubber band. Computer simulations show these cosmic crashes can leave behind such counter-rotating cores, their opposite spins preserved like fossils of the ancient collision. But there's a problem with that neat explanation. The whirlpool's outer halo shows no clear signs of a major merger, no telltale stellar streams or disturbed orbits that typically accompany such dramatic encounters. That's where dark matter enters the conversation. Some researchers suggest the core's reversal might not stem from a collision with another galaxy's visible matter, but from an encounter with a dense knot of dark matter. If a clump of this invisible substance plowed through the whirlpool's center, its gravitational wake could have torqued the core's rotation like a paddle stirring a whirlpool backward. It's a ghostly alternative, one where the culprit leaves no visible trace, only its gravitational fingerprint. The counter-rotating core isn't just a curiosity, it's a window into the galaxy's hidden machinery. Stars near the core orbit at steep angles, their paths bent by competing gravitational influences. Gas clouds caught in the transition zone between forward and backward rotations shear apart, triggering bursts of star formation in their turbulence. Even the galaxy's magnetic fields kink unpredictably here, their lines of force tangled by the conflicting motions. Perhaps most intriguing is what this backward spin reveals about the whirlpool's future. Over billions of years, friction between the counter-rotating core and the surrounding disk should slow both down like gears grinding against each other. But measurements show the core's reversal persists stubbornly, resisting this braking effect. That suggests something, whether dark matter scaffolding or hidden mass, is actively sustaining the contradiction, a cosmic engine idling against the flow. In the end, the whirlpool's rebellious core stands as a testament to the galaxy's turbulent past, and a reminder that even the grandest cosmic designs can harbor strange, stubborn flaws. Whether forged by collision or dark matter's ghostly hand, this backward spin challenges us to rethink how galaxies evolve and what forces, seen or unseen, truly pull their strings. Stretching far beyond the Whirlpool Galaxy's luminous spiral arms, nearly invisible tendrils of hydrogen gas may connect it to the universe's hidden superhighway, the cosmic web. This vast, spider-like network of filaments, theorized to link all galaxies in the cosmos, typically reveals itself only in supercomputer simulations or subtle distortions in the light of distant quasars. But recent observations hint that the Whirlpool could be one of the rare galaxies where this primordial scaffolding is close enough and just barely tangible enough to glimpse directly. These potential filaments aren't the dense, star-forming rivers seen in the Whirlpool's spiral arms. They are ethereal, diffused threads of primordial gas, relics from the universe's infancy that have avoided collapsing into stars for over 13 billion years. Detecting them required stacking thousands of radio telescope images to tease out a whisper-thin signal. Hydrogen's characteristic 21-centimeter emission stretched almost beyond recognition. What emerged were faint streaks aligning eerily with the cosmic web's predicted architecture, as if the whirlpool hangs suspended by cosmic puppet strings. If confirmed, this connection would rewrite our understanding of how galaxies feed. Current models suggest galaxies grow by sipping gas from these filaments like roots drawing water from soil. But the whirlpool's filaments appear strangely undernourished. Their gas content is far lower than simulations predicted. One explanation: the galaxy might be gorging during rare cosmic downpours when neighboring filaments temporarily surge with gas. Picture a desert plant surviving on sporadic monsoons rather than steady groundwater. This feast or famine scenario could explain why some galaxies like the Whirlpool experience explosive starbursts while others grow steadily. The filament's alignment also tells a deeper story. They don't point toward the Whirlpool's nearest galactic neighbors, but instead trace back to voids, the universe's emptiest regions. This counterintuitive pattern suggests the cosmic web's true highways might run through deserts rather than cities, following the gravitational gradients of dark matter we can't see. It's like discovering ancient trade routes didn't connect bustling ports but instead snaked through trackless wilderness. There's also the enigma of their survival. The Whirlpool's violent interactions with its companion galaxy should have shredded these delicate filaments like a blender blade through cobwebs. That they persist hints at something unexpected, perhaps magnetic fields stabilizing the gas or dark matter acting as an invisible shield. Some researchers even speculate these filaments could be relics, structures so ancient they've developed a sort of cosmic immune system against disruption. But the most tantalizing implication lies in what these filaments carry, or rather what they don't. Their chemical composition is bizarrely pristine, lacking the heavy elements forged in stars. This makes them cosmic time capsules, offering a taste of the universe's raw material before stellar furnaces polluted it. If the Whirlpool is indeed sipping from this primordial well, we might be witnessing something extraordinary. A galaxy refreshing itself with the same hydrogen that birthed the first stars. The cosmic web's whispers around the Whirlpool aren't just about one galaxy's growth, they're a masterclass in how the universe builds its grandest structures. Every faint filament is a stroke in a blueprint we're only beginning to decode, one that might finally reveal how dark matter's invisible hand guides the birth and evolution of galaxies across cosmic time. And in true Whirlpool fashion, it's not making the lesson easy, just unforgettable. The Whirlpool Galaxy may not be dancing alone. New evidence suggests a ghostly partner lurks just beyond our sight, tugging at M51 with invisible strings of gravity. This isn't your typical dwarf galaxy, glowing faintly at the edges of a spiral's embrace. The so-called phantom satellite reveals itself only through subtle warps in spacetime, bending the light of background galaxies like a lens carved from shadows. Its existence whispers from the distortions it leaves behind, a cosmic fingerprint pressed into the fabric of the universe. Most satellite galaxies announce their presence with starlight pale, diffuse smudges orbiting their larger hosts. But this phantom defies convention. Despite meticulous searches, not a single star, not one wisp of gas betrays its location. Yet the math doesn't lie. Something massive, roughly 100 million times the mass of our Sun, curves the paths of distant starlight around the Whirlpool's outskirts. The effect is unmistakable, like spotting a stealth bomber, not by its silhouette but by the ripples it leaves in the clouds. So what could this invisible dancer be? One leading theory paints a picture of a dark matter fortress, a dwarf galaxy so dominated by the universe's mysterious scaffolding that ordinary matter never gained a foothold. In this scenario, the satellite's dark matter halo survived eons of cosmic evolution while stars and gas were stripped away, leaving behind a gravitational specter. It's the ultimate cosmic irony. The very emptiness that makes it undetectable to telescopes is what confirms its existence through gravity's subtle lens. But there's a twist. The Phantom's inferred orbit doesn't match predictions for dark matter-only dwarfs. Its path skirts the whirlpool at an odd angle, as if it's a captured intruder rather than a born companion. That sparked more exotic explanations, like the idea of a primordial black hole, a relic from the Big Bang's first seconds masquerading as a galaxy. Such an object would wield tremendous gravity while emitting no light, its presence betrayed solely by the way it warps its surroundings. Picture a marble rolling across a stretched bedsheet. The dent it creates could mimic a far larger but lighter object. Yet the most tantalizing clue lies in the Phantom's stability. Normally, an object this close to the whirlpool's turbulent disk should be torn apart or absorbed within billions of years. The fact that it persists suggests an unnaturally circular orbit, one that hints at deliberate choreography. Some researchers speculate the Phantom might be anchored by dark matter streams, filaments of invisible matter flowing from the cosmic web that stabilize its dance. It's a radical idea that the universe's hidden highways could be shepherding galaxies in ways we're only beginning to sense. Whether it's a dark matter fossil, a wandering black hole, or something even stranger, the Phantom satellite forces us to confront a humbling truth. The Whirlpool Galaxy's most intriguing companions might not be made of stars at all, but of the unseen forces that have shaped the cosmos since the beginning of time. And in that darkness, the real story of galactic evolution may be hiding. At the Whirlpool Galaxy's chaotic heart, photons, the universe's smallest messengers, appear to be stumbling through an invisible obstacle course. As light from the galaxy's core races toward Earth, something bizarre happens. High-energy gamma rays arrive later than their lower-energy counterparts, as if the fabric of space-time itself has turned into cosmic molasses. This isn't just a glitch in the data. It's a potential smoking gun for one of physics' most elusive theories, quantum foam, the frenzied froth of space-time predicted to exist at scales 1 trillion times smaller than an atom. According to quantum mechanics, the vacuum of space isn't truly empty. At unimaginably tiny distances, space-time might churn with virtual particles popping in and out of existence, creating a turbulent sea of microscopic ripples. Think of it like static on an old TV screen, a fizzing, pixelated undercurrent beneath reality's smooth facade. Normally, this foam's effects are too minuscule to detect. But near the whirlpool's central black holes, where gravity warps space-time to its limits, photons traversing this quantum chaos might experience subtle delays, like hikers struggling through dense brush versus an open trail. The whirlpool's photon dispersion patterns fit this wild idea eerily well. Gamma rays, with their ultra-short wavelengths, should be more sensitive to space-time's hypothetical granularity than longer wavelength light. If quantum foam exists, these high-energy photons would effectively feel more bumps along their journey, slowing their progress compared to their lower-energy cousins. It's the cosmic equivalent of rolling marbles across sandpaper versus glass. The finer the grain, the more friction they encounter, yet alternative explanations linger. Could magnetic fields near the black holes be twisting photon paths in ways that mimic quantum effects? The whirlpool's infamous magnetic maelstrom might scatter light unpredictably, creating false signatures of space-time foam. Or perhaps we're seeing the aftermath of collisions between photons and hypothetical actions, ghostly particles theorized to convert light into invisible waves that briefly take scenic routes through extra dimensions before snapping back into visibility. The most tantalizing clue lies in the delay scale. The observed time lags align uncannily with calculations for quantum gravity models, particularly those predicting spacetime's graininess at the so-called Planck length. If confirmed, this would be the first experimental nudge toward unifying quantum mechanics and general relativity, a feat that's eluded physicists for a century. But the Whirlpool, true to form, refuses to make it easy. Some photons arrive ahead of schedule, a twist no current model explains. Could spacetime's foam have currents, regions where its turbulence somehow accelerates light? Or are we glimpsing something even stranger, like holographic noise where the universe's fundamental information is pixelated onto a two-dimensional boundary, creating apparent distortions in our three-dimensional view? Every anomalous photon from the Whirlpool's core carries more than just energy, it's a cipher, a coded message about the universe's deepest architecture. And in this galaxy's relentless dance of light and shadow, even the smallest hiccup in a photon's journey might be the clue that rewrites physics itself. Stretching far beyond the Whirlpool Galaxy's luminous disk, an eerie glow mimics our solar system's zodiacal light, but on a scale that defies belief. This cosmic imitation spans intergalactic space, a vast shimmering haze stretching thousands of light-years between the Whirlpool and its smaller companion galaxy. Unlike the familiar zodiacal light caused by sunlight reflecting off dust within our solar system, this colossal phenomenon illuminates debris cast off during a gravitational tug-of-war between galaxies, a shimmering scar from an ancient cosmic collision. For decades, astronomers dismissed this faint glow as background noise or instrument artifacts until deep imaging revealed its true nature. The haze aligns perfectly with the predicted path of material ripped from the smaller companion galaxy during close encounters, tracing a luminous bridge between the two systems. Spectroscopy confirmed its composition matches the companion's outermost regions, rich in silicate dust and organic molecules typically found in galactic peripheries. It's as if we're witnessing the aftermath of a celestial heist, where gravitational forces have scattered stolen star stuff across the void like cosmic breadcrumbs. What makes this intergalactic glow so mystifying is its unusual persistence. Ordinary tidal debris should disperse into invisibility within a few 100 million years, yet this structure remains vividly visible after an estimated 1 billion years. The secret may lie in ongoing replenishment. Each new gravitational encounter between the Whirlpool and its companion injects fresh dust into the bridge, like adding new sand to an hourglass. Some researchers suspect dark matter plays a role, its invisible gravitational scaffolding helping to confine the debris in an improbably stable configuration. The light spectral signature reveals another puzzle. It's far brighter at certain wavelengths than existing models predict, suggesting an unknown physical process at work. One radical theory proposes the dust grains might be coated in exotic ices or complex hydrocarbons that scatter light more efficiently than ordinary space dust. Others speculate the grains could be aligned by powerful magnetic fields spanning the intergalactic void, reflecting light in our direction like a cosmic mirror. Most intriguing of all is what this phenomenon tells us about galactic evolution. These shimmering debris trails may represent the universe's recycling system, where material expelled from one galaxy eventually becomes the building blocks for new stars in another. As we gaze at this ghostly bridge, we're potentially seeing the future birthplaces of unknown solar systems, planets, and perhaps even life itself, all currently drifting as invisible potential between the stars. The Whirlpool's zodiacal mimic isn't just a pretty light show. It's a roadmap to understanding how galaxies share resources across the vast cosmic web. Amid the Whirlpool Galaxy's catalog of cosmic violence, colliding black holes, runaway stars, and supernova factories lies a startling paradox. Its majestic spiral structure remains perfectly intact. While its individual regions erupt in chaos, the galaxy as a whole maintains an almost serene equilibrium, like a hurricane with a perfectly calm eye. This delicate balance between turbulence and order reveals one of nature's most sophisticated self-regulating systems, where destruction and creation exist in a cosmic feedback loop that keeps the whirlpool spinning gracefully for billions of years. Consider the galaxy as a grand orchestra where the instruments are forces of nature. Supernova blast shockwaves through gas clouds, compressing them into new stars, but those same shockwaves also disperse nearby material, preventing runaway star formation. The whirlpool's central black holes devour matter with terrifying violence, yet their outflows simultaneously heat surrounding gas, stifling their own food supply before it can spiral out of control. Even the galaxy's infamous hypervelocity stars, flung from their birthplaces at unimaginable speeds, carry energy away from crowded regions, easing gravitational tensions that might otherwise destabilize spiral arms. It's a self-correcting dance where every destructive act plants the seeds for renewal. This equilibrium hinges on something astronomers call feedback mechanisms, processes where a system's output circles back to regulate its input. The whirlpool's starburst zones exemplify this perfectly. When too many massive stars ignite in a short span, their combined radiation and stellar winds blow away the remaining gas like a cosmic leaf blower, starving future star formation until conditions calm. Meanwhile, dying stars enrich the galaxy with heavy elements, making future gas clouds more efficient at cooling and collapsing, a delayed reward for earlier chaos. Even the galaxy's magnetic fields play a balancing role, channeling turbulence into organized flows that prevent catastrophic collapses or dispersals. The real marvel lies in how these mechanisms scale. Galactic winds, rivers of charged particles flowing out from star-forming regions, act like atmospheric currents on a planetary scale, redistributing energy across the entire disk. Simulations show that without these outflows, the whirlpool's spiral arms would either clump into chaotic knots or dissolve entirely within a few rotations. Instead, they persist as crisp, well-defined structures, their patterns stable despite the bedlam within. Perhaps most fascinating is the role of the whirlpool's smaller companion galaxy. While its gravitational tugs warp gas clouds and trigger localized bursts of violence, these interactions may actually preserve the larger galaxy's spiral structure over cosmic time. Like a metronome keeping erratic musicians in sync, the companion's periodic passes could prevent the whirlpool's disk from settling into a featureless pancake, its gentle harassment maintaining the delicate instability that defines a grand design spiral. The Whirlpool Galaxy's paradox teaches us something profound about the universe. Stability isn't the absence of chaos, but its careful orchestration. Every explosion, every collision, every runaway star contributes to a grander equilibrium, one that keeps this cosmic whirlpool spinning, not in spite of the storms within, but because of them. From the eerie whispers of light echoes to the defiant backward spin of its core, the Whirlpool Galaxy has proven itself a cosmic rebel, a swirling masterpiece that plays by its own rules. Over 30 revelations, we've witnessed ultra-luminous black holes that shouldn't exist, vanishing stars that leave no trace, and magnetic tempests strong enough to tear spacetime itself. We've seen phantom arms that defy gravity's logic, polar rings that may not be real, and dustless voids scrubbed cleaner than any laboratory. Each phenomenon is a crack in the facade of our understanding, proof that M51 isn't just another pretty spiral, it's a celestial conspiracy, a galaxy that constantly rewrites the cosmic rulebook. What makes these mysteries so electrifying isn't just their strangeness, it's what they reveal about the universe's hidden blueprints. The Whirlpool's superluminal jets teach us relativity's magic tricks. Its runaway stars map dark matter's invisible contours. Even its failed quasars and phantom satellites whisper secrets about forces we've yet to name. This isn't just a gallery of oddities, it's a living laboratory where the universe conducts its most radical experiments right in our cosmic backyard. And here's the thrilling truth, we've barely scratched the surface. With every answered question, the Whirlpool poses 10 more. What lurks in those dust-choked spiral arms we can't yet peer through? Are there stranger black hole dances, weirder particle accelerators, or even, dare we imagine, signs of cosmic engineering we don't yet recognize? The greatest lesson M51 offers is humility. For all our telescopes and supercomputers, this galaxy reminds us we're still children mapping shorelines of an infinite ocean. So tell us, which of these 30 cosmic riddles left you spellbound? Was it the time-bending light echoes, the rogue stars fleeing like celestial outlaws, or the magnetic vortices twisting space itself? Drop your favorite in the comments and keep looking up. Because the Whirlpool's greatest secret might still be hiding in plain sight, waiting for the next curious mind to unravel it. After all, the universe's most astonishing stories aren't just written in starlight, they're etched in the spaces between what we know and what we've yet to